Good morning, students. Today we're going to learn about modern periodic table for class 10. As is already known that the modern periodic table was framed by Henry Moseley, and he framed the modern periodic table based on vertical columns, that is called as groups, and horizontal rows called as periods. Now, there are around 18 groups and 7 periods in a modern periodic table. Now here is how a modern periodic table looks like. We can see over here there are 18 groups. You can see group number 1, group number 2, group number 3, 4, 5, 6, so on and so forth till group number 18. Now there are 7 periods that also we know. We can see over here period 1, 2, 3, 4, 5, 6 and 7. Now the question over here arises. How do we put each element in different groups or periods? In order to understand how we put elements in a group, let's take an example. Here I'm taking an example of group number 17. We can see over here group number 17 comprises of elements such as fluorine, chlorine, bromine, iodine and astatine. And when we shall take out their electronic configuration, we can see over here that the elements of group number 17 ends up with 7 electron in the valence shell. Thus, we can say that the elements put in the groups are based on the electrons present in the valence shell. If the element has 1 electron in the valence shell, they are placed in group number 1. If it is 2, group number 2. If 6, it's placed in group number 16 and so forth. But what about elements put in the same period? On what criteria or conditions do we put elements in the same period? Let's take for example period number 2. We can see the elements present in period number 2 is beryllium, boron, carbon, nitrogen, oxygen, fluorine. And of course lithium was the first element. Anyways, coming to the structures, you can see over there that each element has got two shells in the atom. As a result of this, we can say that in a period, those elements are placed which have the same number of shells. Now with this idea, what all the things can we learn? We can see one thing for sure, that when elements are placed in same groups, they all shall be possessing the same chemical properties. Now the question arises, what enables them to possess the same chemical properties? Well, before coming to what helps them to possess the property, we should first understand the phenomena called as periodicity. Now what is a periodicity? It's a phenomena of recurrence of the similar properties of an element after a regular intervals of atomic number. Now, so therefore we can say whenever an element is arranged according to the increasing atomic number, the property of one element will be repeated in another element. As example, we can take once again group number 17. Now, these elements are placed under a very reactive group series called as halogen. The special property of halogens are that they are very reactive in nature and immediately they'll combine with any substance in around it to form the respective compounds. So now while talking, what property enables them to be so reactive is the presence of valence electron number 7. We all know that elements having 7 electrons in the valence shell requires just 1 electron to complete its octet. And as a result of this, they will be reacting with other elements, taking 1 electron from them and becoming a stable electronic configuration. As a result, we can say that the chemical property is owed by the presence of electrons in the valence shell and the number of electrons either lost, gained or shared amongst them. Now, the amount of electrons lost, gained or shared is basically termed as valency. Now talking about valency, we should know this thing, that valency of an element is called as the combining capacity of the element. Now whenever an element combines with other elements, it has to either lose electrons, gain electron or they have to share electrons. And the number of electrons involved in these three activities is called as its valency. And what we have to learn over here is that the valency of metal generally lies between 1, 2 or 3, and that of non-metal lies between 3, 4 and 5,